All right. Good morning, or good afternoon, or good evening, or good night, whatever time it is for you working from home, Conf. My name is Nash. I am delighted to be first to address you as part of this exciting set of online talks we're starting to now have. And I'm going to talk to you a bit about passwords today. Indeed, fantastic passwords and where to find them. Just in case you need to find me online at all, and please do if you have any questions about this. I'm all over the place as Phil Nash, and Phil Nash on Twitter, Phil_Nash on Twitch, which is hopefully where you're watching right now. I'm a developer evangelist for Twilio. Twilio, if you don't know, is a communications platform. That means you can use it in your applications to do things like send or receive text messages, make or receive phone calls, or do video, fax, chat, anything you want to. Again, any questions about that, just find me online and ask me. So let's talk about passwords. I'm going to tell you my first password. I'm not going to tell you my latest passwords because they're all horribly long and made of horrible characters and I don't even know them myself. But just as a way to illustrate how passwords are terrible, I want to share with you my first one. Sorry, in the background, I was getting the stream of myself. That's all very weird. My first password, there we go. I set it during school. It was for the school computer system, and I was not particularly creative at the time, apparently. So I set it to Nash, all lowercase, 4 characters. Pretty strong password there. I think you'll agree. And of course, my friends eventually guessed it and hacked me and got into my email account. But because I was like 12, there was nothing interesting for them to get out of that. I did change the password after that, and I learned my lesson. I picked a much harder password to use instead. Still 4 characters, still lowercase, the word atom, because apparently I was a super geek at that point as well, and just wanted to talk about bits of particles. Terrible. But what the problem is, so we got hacked, yeah, and I obviously learned my lesson. But the problem is that passwords in general are just terrible. We don't have much better. So what else can we blame? How about the guidelines? Password guidelines are roundly just terrible. You've probably seen them before, right? It's something like your password must contain at least 8 characters, a capital, a plot, a protagonist with good character development, a twist, and a happy ending. Or, something a bit more like it should have uppercase letters and lowercase letters and numbers and special characters. And this is great, right? It takes us from using passwords like password, a particularly weak and horrible password, to a password like password 1 bang. An incredibly strong and powerful password that no one ever will guess. I hope you agree with a certain level of sarcasm in the talk, but this is not really helping us. And there's further guidelines as well, of course. This one, you probably had this one as well, which is, to check passwords regularly. And so we had password 1 bang as a password. So what do you do when you get asked to change that password? Is obviously you start adding characters, and you can do it again, and this can go on forever. Or, you could go on password 2, password 3, or password 1, password 11, password 111. Any kind of character pattern so that we can remember our password, or so that any user can remember their password. And this is what these guidelines force us to do. It forces us into patterns. And the problem with patterns is that makes them much easier to brute force. Because if you had to have all of those characters, but also in some kind of random thing, like any password generator will do for you, it would be hard. But what we're really doing is taking passwords that look like this, or in fact, passwords that look like this, right? An uppercase letter, a bunch of lowercase letters, some numbers, and a special character at the end. And, the number's normally 1, and the special character is normally an exclamation point. And the word with a capital letter and lowercase letters is normally from the dictionary. And all we've done is we have cut the space of the potential passwords that we could be using down from that amazing amount of things, from all those characters we could be using, to much fewer. And it sucks. And this is what people do. And I can prove it. I have an example. You see, just a couple of years ago, 2017, 2018, the Western Australian government had a security audit of the passwords of their employees. And they checked and they assessed 234,000 passwords, which is a pretty good measure, I think, of how people like to use passwords. And they deemed a quarter of them to be weak passwords. Now, well done the 3/4 of people who did strong passwords and presumably then attached them to their monitor using a post-it note. But a quarter of passwords were deemed weak. In fact, 1,400 of those passwords were password 123, not even an exclamation point there. And we actually have the top 20, which I like looking at these kind of things, seeing what passwords people use. Because obviously there are some passwords that are denied in here. You can't have it too short. You can have it without numbers. So password actually comes in at number 9 down the bottom here. But there's patterns in this as well. We have password 123. We have just password 1, password 2, password 01 for somebody who's planning to stay around for, I guess, more than 10 cycles of changing their password, and they were padding that number ready for it. And then there's other patterns, like the date that they probably had to change their passwords. I like this because somebody had to make their password. Quite a lot of people made their password in October 2017, I'm imagining, or in spring 2017, a popular time to change passwords. And then my favorite one on the whole list is number 18 down here, Logitech 1, because presumably the people having to change their password at that point looked all around their desk and like spied their mouse on the keyboard or something and went, yep, Logitech, that'll do. It'll always be there to remind me. So yeah, these passwords all follow that pattern. And as I said, there's no special characters in this. We just have capitals, lowercase letters, and then a number of some sort, sometimes a year, which makes it even easier. So that sucks. Let me tell you instead about what I thought for a while was my best password. No one's ever guessed this password, but we'll see a bit more. I'm not going to tell you it either because it might still be hanging around somewhere. But my best password was 8 characters long. Not super long, I know. Not great. It was made of numbers and letters, but uppercase letters only. I could, I had some variations with some lowercase letters in it, but normally it was uppercase. And it was the model number of a piece of hi-fi equipment I really wanted to buy. And I kept looking at it a lot because I was really excited to buy it, and so I ended up knowing the model number off by heart. And then when I had to set a password one time, that came straight to mind. Nobody ever guessed it. The problem is, I still got hacked. I lost access to my Skype account, which is actually how I'm talking to you right now. I got back the account, thankfully, and my Spotify account, both on the same day. Both because they were using the same password with the same username with my email address. And that's because I used that password everywhere. I thought it was a great password, so I used it everywhere. And that was not a good idea. And many people do this as well. It's not a good idea because it doesn't matter how good a password you have. If you use it everywhere, then some other site is going to give it up for you or give it up for whoever you are. And there are more and more kind of user data breaches every single day. I know my password, username and password in this particular case, appeared in the Adobe breach and the Dropbox one, the Bitly one, Last.fm, LinkedIn, DISQUS, and Tumblr. That allowed other people to take those breaches, take that data, and stuff it into our sites and see if they got anything. And they did. They got my Skype account and they got my Spotify account. I got them both back. The Skype account was very weird because I found that a whole bunch of French men had been propositioned for marriage using my account over the chat. And I have no idea why. And some were actually into it as well. So I really don't know what was going on there. Especially because it still had the name, like username Phil Nash, even if they changed the display name to a French woman's name. Very strange. So we can't trust these sites to look after our passwords or our users' passwords, indeed, either. And if you are wondering if you've been hacked, breached like this, you need to know about the site haveibeenpwned.com. It is run by Troy Hunt, and it is a collection of all the public data breaches that can be found, and will send you notifications if your email address, if your username email address turns up in a breach. So get on there and sign up and find out how many times you've been breached, and sign up for notifications to when you get breached again. It's horrifying. So how do we fix this? We're developers, and we have users of our applications who are probably making use passwords. How do we make it so that their password is not repeatable every time, so subject to being breached from other sites, and also not subject to brute force attacks because they're just falling into a pattern based on those terrible old guidelines for passwords. How do we fix it? Well, first up, the guidelines were wrong. It's not just me saying this. The original guy who wrote it, he worked for NIST, the National Institute of Science and Technology in the US, wrote a few years ago how they were wrong. And indeed, NIST, as well as other security firms, have changed their tune on what passwords should be since. And hopefully you've seen this XKCD comic before. It is one of the more famous ones. And it shows that why those guidelines were wrong. Because even if we pick the original guidelines and actually use, uncommon words and substitutions and capitals and special characters and even have potentially questionable orders on those patterns, it's still the pattern. And in this comic, it calls that password Troubadour N3. It says it has around 28 bits of entropy, which will take around 3 days to brute force 1,000 guesses a second. 3 days is just, that's easy. But it's hard for the person to remember. Meanwhile, for a 4-word passphrase, comes out at 44 bits of entropy and will take 550 years to guess. And is much easier to remember. But how do we make our users do this? Well, let's check out those new guidelines, first of all. These are guidelines that are agreed upon, actually, by both the ACSC, that's the Australian Cybersecurity Centre, the NCSC, National Centre for Cybersecurity in the UK, and NIST. And those guidelines say that passwords should be at least 13 characters. And if you take away one thing from this talk, just one, it's make your password restrictions just at least 13 characters. Just make passwords longer. That is going to break most attacks on them. Most people are probably not using a 13-character password unless they're using a password manager, which most people are not. And so to make them at least 13 characters, that's probably going to mean somebody's picking a new password. Secondly, accept all characters. Don't block because of spaces or emojis or anything. Passwords can be, they should be any text, it doesn't matter. It widens the space, the attack space, the entropy space. And don't allow insecure passwords. And this means a few things. It means don't allow dictionary words. That's pretty cool. Do not allow repeated or sequential characters, such as 6 A's in a row, or patterns 1, 2, 3, 4, ABCD, or QWERTY, or whatever. Don't allow context-specific words. Don't allow the person to use their username as their password, or their email address, or the application name that they're signing into. And do not allow passwords that have been in a public breach. Now, this one's kind of interesting, we'll come back to it in a bit. So how do we work with this in Node? I think a lot of the things today are about Node. This will count for a lot of things, but this is a library kind of bit we're talking about. So how does it work in Node? Libraries, you can go and find your own, or ask me later if you have other languages you want to do this in. I have some suggestions of a couple of libraries. Well, not necessarily libraries. Again, make passwords longer. Remember that one. Alternatively, I quite like Password Validator. This is a great little NPM library. You do have to be careful of this one though, because you can get it wrong. Because Password Validator is great. It allows you to create a schema to validate a password against, and that schema can have the options that you want in it. However, you could have a schema which has uppercase, has lowercase, and has digits in it, and doesn't have spaces. For example, this is something you can do. Don't do that. Instead, we could do a password validator schema that has at least 14 characters, make passwords longer, is up to 255 characters. We can limit the top end so that people can't throw giant strings at our validations and break our applications from the inside. And maybe, it's not one of a list of passwords, a list of known passwords, or a dictionary list in this case. And if you make a schema like this and then validate a password with it and pass a list as true to that, then you get a list of the things of the schema that it did not pass. In this particular case, it's not long enough, and it's one of the words we gave. So you can make good schemas with Password Validator if you consider the rules that we've set. And then the other one is, let's go, ZXCVBN. That one would seem hard to remember, perhaps, and say and type, but it's not. If you're sitting at your keyboard right now, which I think you probably are, if you look down, then the letters on the, and if you have a QWERTY keyboard, the letters on that bottom row start ZXCVBN. And ZXCVBN is great. It was built by Dropbox, and I'm going to show it in a quick demo right now, whilst I continue talking about it. So I'm just going to call it Z here, because I'm going to stop having to type all of that every time. But ZXCVBN takes passwords and then runs it through a whole bunch of checks and gives you a whole bunch of information about a password. In the password, for example, it's a dictionary word. It can be calculated in about 108 seconds, or yes, less than 2 minutes. We have words for this. It has feedback on it saying, hey, this is a top 10 common password. Maybe you want to add another word or two, or use uncommon words instead. And it has a score. The score ranges from 0 to 4, where 0 is you really, really shouldn't use this password, it's already been hacked, to 4, which is this will never be guessed. So if we tried another password, for example, let's go for correct horse battery staple. We can see that this one, whilst it definitely has dictionary words in it, which is possibly a problem, the calculation time for it to be cracked would be centuries, and its score is 4, and there's no feedback for this. But don't use correct horse battery staple, that's all over the internet, anybody could guess that. So ZXCVBN is great. It also works on both the client and the server side, although beware of the client side because it brings a whole dictionary with it, and that is not good for your bundle sizes in the front end. Great if you only load it conditionally when you need it. Think about that kind of thing. But it's great because it then also matches the front and the back end, and there are actually ports of ZXCVBN to a whole bunch of other languages as well, if you need that. But how about those insecure passwords, those breached passwords? This is something worth thinking about as well. Thankfully, Have I Been Pwned also has an API for this, the pwned passwords list. So pwned passwords is 555 million of those passwords previously exposed in data breaches. That's quite a lot of passwords, but thankfully there's plenty of others available to us. And so it has an API, which you could be worried about because this is a passwords API. If we just start sending passwords over the wire to Troy Hunt, that's not a good idea. That's just another breach password every single time. But that's not how it works. Instead, it works like this. You get the SHA-1 hash of that password. You then take the first 5 characters of the hash, send that to the API. That's kind of this API here with the prefixes at the end. And that sends you back a list of all of the hash endings to that prefix that appear in the database. So the API doesn't know which password you sent it, just that first 5 characters of the hash. And we just check if the remainder of the hash is in the result. There's a bunch of libraries for this as well, and I did want to show you my one because I made one and I think it works. And I also like to show off that some of these things are ridiculous passwords as well. So if we just take P and look at password, for example, we can, it's an asynchronous API because it's going to call off to the API. That's a password is pwned, and there's 3.7 million versions of it. It's also worth noting that correct horse battery staple does also appear in here 3 times, which is bad. I also know that my best password I talked about earlier, that's in there 8 times, probably on my account, I think. And then I really like this as I was exploring things earlier, that just 8 stars in a row has been in there 7,000 times. Who thinks that's a great password? Not me, but we have to help people here. It's special characters, at least. I'm after a little bit of help with this, just because it's open source. I want to make it the best way of doing this, and on the client and the server side as well, and I haven't quite managed that yet, but we'll get there. So go find it on GitHub. So I'm going to wrap up a little bit. There's one more thing. The next level, we can do as much as we can with passwords, but if people are going to be write terrible passwords anyway, then we can help them out with 2-factor authentication. That is our next level of things. So consider that if you want to develop a secure thing for your users and make them worry less about their passwords. So in conclusion, yeah, passwords are terrible. Sorry about that. Password guidelines are worse, or at least the old ones are. So let's have a look at those new ones and try and implement those. Make passwords longer, 13 characters at least. All the security, cybersecurity departments believe that, agree with that. And check against those breaches and dictionaries. Do not allow passwords that have been breached. Do not allow common dictionary words. Terrible ideas. And finally, implement two-factor authentication. If you want to find out more about how to do that, also hit me up online. That's all I've got time for. Have a great working from home conference. Thank you very much for joining us to the start, and I'll see you in 24 hours for the end of this as well. I'll be hanging around in the Twitch chat, so I'll see you there. Thank you. Stay safe. That's it. My name is Nash. Thank you very much.